Hello, this is Russell Hawley coming to you from the Tate Geological Museum in Casper, Wyoming. And today I'd like to talk to you a bit about the Ordovician Period, which is a long, long time ago. It started 500 million years ago and ended about 439 million years ago. So this predates the dinosaurs by a pretty substantial margin. If you could go back in time to the Cretaceous period and look at the Earth from space, you'd say, hey, look, it's the Earth. And then you'd notice some differences, like the shallow seaway that divided the United States in half, or the fact that India was an island at that time. But if you went back to the Ordovician and looked at the Earth from space, you would say, what planet is that? It would be utterly unrecognizable. And this is why. During the Ordovician, the continents were joined together. There were two major continents, supercontinents you might call them. One of them composed of the southern continent, Africa, South America, Antarctica, India, and Australia, all joined together in a great big supercontinent called Gondwana. Meanwhile, Europe, Northern Asia, and North America were joined together in another northern supercontinent called Laurasia. And many times during the course of the Ordovician, that supercontinent of Laurasia would have been divided up by shallow epicontinental seaways, flooding the lower parts of the lower elevation parts of that continent. At any rate, you certainly wouldn't be able to recognize any shapes that you see on a modern map. Now, at the beginning of the Ordovician, the weather was quite warm globally, and large areas that are dry land now would have been covered by seawater. Here is what the western United States looked like during the Ordovician. Wyoming, and indeed the entire rest of the United States, was underwater at that time. And that's why we find dolomite in Wyoming. The Bighorn dolomite dates from the Ordovician period. And dolomite starts out as limestone, and then it gets altered diagenically. Nobody's entirely sure how, but certainly the presence of dolomite in Wyoming shows us that we were underwater at that time. Now, as the Ordovician went on, the climate of the world got steadily cooler and cooler and cooler. And this is what the world would have looked like at the end of the Ordovician. Probably the cooler temperatures were because of the fact that the South Pole was covered by dry land at that time. That always allows snow and ice to collect there, and that has an effect on the global climate. So ironically, the part of the world that today is among the hottest and driest parts of the planet, the Sahara Desert, was covered by an ice cap, and the surrounding oceans would have been filled with icebergs. Now, I couldn't resist an opportunity to show what that looked like. And so down here is a drawing of the Sahara Desert, probably around 440 million years ago at the end of the Ordovician. This would be more clear if it was in color, but these are supposed to be icebergs floating in the ocean above. And here are the various creatures of the Ordovician living in the waters below. We find the shells of straight-shelled cephalopods, orthocones. These would have been swimming through the oceans of the Ordovician. And then other fossils give us an idea of the critters that would have been crawling along the sea bottom. Our old friends, the trilobites, were very abundant. We've got some here. Two of them are fighting. This one's trying to eat this one, so he's curled up into a ball for protection. These ones are swimming in the water column above. We can figure out what trilobites were doing with their lives by comparing them to modern arthropods. They're not too different from horseshoe crabs or isopods. But then there's some creatures that are a complete mystery. Dendrocystites here, for example. What's its lifestyle? Hard to say. What can you say about the habits of a creature that looks like a cross between a sand dollar and an electric guitar?